Hi, this is Soo Ye
and Hyeonjun
from the Korea Advanced Institute of Science and Technology, the first authors of KOALANet Blind SuperResolution using Kernel-Oriented Adaptive Local Adjustment. We've equally contributed to this work, advised by Professor Munchurl Kim. I'll be narrating the first half of this video, and Hyeonjun will narrate the second half. Super-resolution networks are usually trained with bicubic downsampled images. Their performance tends to drop under even slightly different conditions. This is where blind super-resolution comes in, as it aims to handle more generalized or even unknown degradations. A real low-resolution image contains various types of degradations, which are often modeled as kernels. There's a usual blur due to the intrinsic camera characteristics that tends to be spatially equivariant across the image. Often, there's also an intentional blur by adjusting the depth of field of the camera, which tends to be spatially variant due to some areas being in focus and some out of focus. A good blind SR model should appropriately disentangle these mixed blur characteristics, removing the degradation blur and leaving the intentional blur as is to maintain the photographer's intent. We propose a blind SR framework that jointly learns the degradation and restoration kernels instead of directly predicting the output image. Both kernels are spatially variant to account for the complex blur characteristics in an image. We also present a new KOALA module that applies spatially variant local filtering on the SR features based on the estimated degradation kernels. These KOALA modules can be inserted into any CNN for incorporating additional information in image restoration tasks. This is our full network design, containing a downsampling network at the top and an upsampling network at the bottom with the proposed KOALA modules. Both networks predict spatially variant local kernels, and the estimated degradation kernels are fed into the KOALA modules to be used for a degradation-aware SR. Hyeonjun will now go over the details.
The UnitBased Downsampling network takes an error image and predicts its underlying degradation kernel for each pixel. The predicted kernel and the HR are locally filtered to reconstruct error, which is used to calculate the error reconstruction loss. This indirectly reinforces the predicted per pixel kernels to be spatially variant. The upsampling network also takes an error image to be upscaled. In KOALA modules, the early feature maps are adjusted through the element-wise multiplication and local filtering based on the predicted kernel. By doing so, unwanted features related to the degradation could be removed from the original info features. To analyze how the KOALA model works, we visualize the kernels. The first row shows the examples of the kernels estimated by the downsampling network. The second row shows their corresponding learned local filters in the KOALA model. Even without any enforcement on the shape, the local filters are learned to be related to the orientations and shapes of the degradation kernels. Here are the experimental results. This table shows PSNR and SSIM for the various methods on the anisotropic degradation test set. Our method outperforms all compared methods. We compare the visual results. We also visualize the mean of the estimated spatially variant kernels. Our method restores sharp edges and the details for the various types of degradations. This figure shows SR result for the downscaled shallow depth of field images mixed with in-focus and out-of-focus regions. IKC and zero-shot SR with kernel gun tend to oversharpen even the intentional blurry area. In contrast, our method leaves the originally out-of-focus region blurry and upscales the overall images that are closest to the original images. In this experiment, we qualitatively verified the effect of the provided degradation kernels. With the help of the accurate kernel, the KOALA model effectively removes the blur compared to the baseline. When the incorrect kernels are deliberately provided in the third column, the upsampling network produces oversharpened or blurry result. All relevant code and data are released on GitHub. Please visit us at session 8 for any further discussions. Thank you.